Okay, let's start by taking a look at Piscine Detect. So as I mentioned, this is probably our first notebook that we've ever used for many of us, so let's go ahead and get started. So again, key here is when you open a notebook, I'll drop the link both in our syllabus and in the YouTube video notes. You'll want to come over here and hit connect. So make sure you have this notebook open and you're in Colab, and you should have probably by now either bought Colab Pro or Colab Pro Plus. So it should say either Pro or Pro Plus here. If you have multiple Gmail accounts, you may need to switch between them. You can do that over here. So make sure you're in the one that you paid through. Go ahead and hit connect. And once we're connected, it should say a green check mark, RAM disk. So the other thing I generally recommend that I first do is just open up your folder panel. So go ahead and click folder. And now, obviously, like there's more notes here if you want to read through it later. But for now, the key thing to know about Piscine Detect is we don't need to use a GPU for it. So let's make sure we're not paying for GPU credits, because remember, GPUs cost more than regular CPU units. So we'll go ahead and run this first cell. We'll do that by either clicking into the cell and hitting Shift Return or pressing the play button. And we should get an error message. And this is what the error message says. It says bin/bash line 1, NVIDIA-SMI command not found. That means there is no GPU running. So this is a good error to get in this case. And you'll see that's noted here. This is what we should see. Next, we want to connect to our Google Drive account. So in this case, you probably, again, want to make sure that you're paying on the account you also have the largest Google Drive amount in. I happen to be in my NYU account, which means I have unlimited space, which is why I'm using it for this class. We'll run this cell. So go ahead and hit play here. You'll say you sure you want to do this, and you'll say yes. And you'll need to go in here and hit and click on your account again, and you'll need to approve the usage of this. We will pretty much do these first two steps in every notebook we run, just so we get in the habit of doing it, and also just so we're always connected to Drive. So now it says mounted at /content/drive. But if you look over here, you don't see it. This happens pretty commonly. The way to make sure you see it, well, there it went, it popped up. So it does, after a couple seconds, show up. The other thing to do is hit the refresh folder button, which is right here. And now we've got Drive, and if I look inside of my Drive, you go into Drive, My Drive, you'll see I've got a bunch of files in here. It's because I've taught many classes using this, so my folders might be a little bit crazier than yours. Apologies for having to dig through this mess. I'll try to make it as simple as possible, just so everyone's aware. What I might recommend you do is, just for your own sanity, make a new folder. So you can do that by right-clicking on the folder you want to create it in, and do new folder. And let's just call it Algo Film. So we'll just make a new folder there, and this is weird because it's like alphabetical but starts with capitals. It's kind of a funny thing about Colab. You'll see it is right here, Algo Film. So next we need to actually install the Piscine Detect program. The way to do that is to run this cell. Don't worry about what this means, but for those of you who are programmers, we're using pip, which is a Python installation program, and it basically runs all Python stuff. Pretty much everything we're going to look at in this class is Python or Bash. So that is now run. We'll hit check. There's no real way to check to make sure it exists. So just we know it ran correctly. We didn't get any error messages there. Next, let's find a video. So there's two options here. One is we can either upload a video directly that we've either found on the internet and downloaded, or our own footage. I mentioned we would look at YouTube downloads, so we'll look at that. So actually use YouTube DL. This is actually not YouTube DL. It's like a fork of YouTube DL. It's slightly better, but whatever. This is fine. So again, we need to install this. So we're going to run this cell. It shouldn't take more than a couple seconds just to run. And then we're going to, we can look at the help options. This would allow us to see all the options. Those of you who are into programming probably know this is really helpful to see. I'll actually not show this just for this demo, just because it's not super important. But the main thing is we need to find a video, and then we're going to output it as an MP4 with M4A sound. And then we're going to output it to a certain location. And this, if you've ever looked at YouTube, is the video ID. So let's go to YouTube now, and let's just find a video. So I'll just search for like classic movie trailers. And you'll see here we've got some classic trailers. That's funny. Oh, it looks like there's a couple here. Yeah, let's do Groundhog Day. That kind of makes sense as a. This will be kind of a funny one. Let's try this. So let's do Groundhog Day. So we'll click in here, and you'll see that at the top where the URL is, you'll see the v equals, and then we get this code. This is the video ID. So this is what we want to grab. So let's go ahead and copy this. We'll come back to Colab, and we're just going to paste that in here. Leave everything else as is, and we'll paste this in. So this says download from YouTube that video, but then we want to set the output path. And if you notice, this doesn't really match up with what we want to do. So let's do this. So let's do our algo film. So we can right click onto algo film and hit copy path. And then let's just paste that in. So we'll cover all of this up until the -O, paste that in. And then let's give this another folder name. So let's say downloads. And then let's say Groundhog Day.mp4. Now you could go and grab whatever film you want to from YouTube. I generally recommend trying a trailer to start with because they're short. So grab that and then make sure you just name this the same way. If you did make the algo film folder like I did, just make sure that you don't need the downloads folder, but just make sure it's in a place where it kind of makes sense. I'll just leave this as is, and we'll just run this, and you'll see how quick it is. This is now downloading. You'll see ETA is a couple seconds. Download emerged, and if I come over here and I open up the algo film folder, you will see in here is downloads, and in here is Groundhog Day. Now, there's really no good way to play video directly in Colab, unfortunately. If you want to check to make sure this video downloaded correctly, you could just download the video and then watch it. I know this is going to work correctly, so I'm not going to do that, but that's probably the easiest way to look at video inside of here. Your other option would be to go to your Drive account. Go over here, Drive, make sure I'm in my NYU account. And you'll see groundhogday.mp4, which is right here. And it should play. Looks good. Okay. So we've got our video in here. Now we just need to use PyScene Detect to actually remove all the pieces. So again, I left this in here for anyone that wants to run it. If you're interested in all the options, you can go ahead and run that. What I've done is I've actually set it to be the most common options for what we're going to do. So below here is actually the cell we want to run. And you'll see here, this is set up more like a GUI where there's just 2 input paths. So first off, we want to set our video path. So the way to do that is to come over to our folder and just right click on the MP4 we made and hit copy path. And then we will select all of this and we'll paste it in. So this is the link to our folder. And then what we want to do here is let's make a new folder and let's just call it clips. So we'll call this clips. And then maybe for our own sanity, let's also go in and make another folder just so we've got these sort of, let's call it Groundhog Day. You'll notice that I'm usually in the habit of never leaving spaces in folder names. In my experience, adding spaces creates a lot of drama for you using these tools. So in general, don't use spaces. It's just generally better. So use dashes or underscores, whatever. Next thing we want to do is let's actually just copy this path and paste. So what we're doing now is we're going to say take this video, this .mp4, and convert it into a bunch of clips that go into this folder. So at this point, we can just go ahead and hit run. And you'll see here, it is now giving us progress. If I had to guess, this 3814 number is how many frames are actually in the entire film. It's a pretty short video clip, right? It's what? 2 minutes and 39 seconds. That probably sounds about right for the amount of frames that would be in it at 24 frames per second. So it's now going through and just detecting where the breaks are in this. So again, for anyone interested in sort of the technology that goes into this, it's a little more complicated than just looking at each individual frame and then looking at the next one and seeing how much difference there is. There's some other neat little tricks it does, but for the most part, it's just literally going to go through each frame one by one and say, based on this frame, is the next frame drastically different from the previous frame? And if so, that constitutes the beginning of a new clip. So it's going through and analyzing all of this, and then once it's done, it's actually going to go out and create each individual clip from it. You'll see it's going in and outputting these. And it looks like it's going to take about 5 minutes. So 5 minutes, for a 2-minute long film, you might think, man, that's a lot. But also remember that a film trailer tends to have a lot of cuts in it. Trailers, are made to be very fast, catch the whole sort of idea of the film. But the idea is just lots of small little cuts in order to make a 2.5-minute long trailer. But again, if I had to go through this film one by myself, imagine that I was scrubbing through this and trying to find each cut, there would be a lot of cuts in this, and I'd have to do that all manually. So this tool is actually much, much quicker than that. So it actually is quite good, and it's also quite flexible. It does a little bit more than just frame to frame, because one of the challenges with frame to frame is that if there's a blend or a crossfade, it might miss that. So it does do some stuff to try to work around that sort of thing. But anyway, this is now going to run. When this is finished, actually, I bet if I go in here now, if I go into clips and open this, you'll see it's already generating all of my scenes. You'll see it just says scene 001, 002, all the way down to what we have right now, which is 24. And it looked like, based on what it told me up here, it looks like there should be 91 or 92 scenes. So already we're starting to see the average shot length of a trailer is 1.7 seconds. But if I were to run this on a full film, that this would then be different. So while this works, let me actually show you also, if you don't want to use YouTube, how you would run this on just a video that we're uploading. The way to do that is, let's go back to our Drive folder, and let's assume you've already made all of your clips, right? So let's come in here. Let me just do show file location, algo film, and clips. So let's assume that you don't have Groundhog Day in here, but you just have already produced some video clips that you didn't use YouTube to find. So I've got one here on my desktop, which is this thing. So the Library of Congress makes these cool little videos of some old time films, or basically produced on paper, I guess. I don't know. Anyway, that's a story for another day, but I've got this cool little video. Now, the thing is, I notice in here, there probably is no actual shot difference, right? There's these end credits and opening credits, but there's no actual shot here. So this would be kind of interesting to see if we get just that one complete shot, or if, because it's flickering, if it actually finds detection scenes. So let's just try it. So again, probably the easiest way to do this is just go into Drive and just make a new folder here. So we'll right click and we'll call this NYC dumping. And we'll open this and we'll just drag our video in here. Now, I always recommend that you do this in Drive rather than, you could actually go into here and you could also make a new clip and then drag the clip into here. I personally have found that dragging files into Colab and uploading them through Colab is very slow, half the speed of Drive. They're doing something on the back end to make this faster. So when you upload directly to Drive, it will upload much, much faster. So I definitely recommend doing that here. And you'll see this, this is a .mov file, so it's pretty big. It is 260 megabytes, so it's quite large. But it's still going to only take a minute to upload on crappy New York City internet. If I come back over here and I hit refresh on my folders, you'll see, not necessarily instantaneously, it takes a couple seconds, but already you'll see NYC dumping as a folder is here. And then, and actually upload that to the wrong place. Well, okay, we'll fix that in a second. Because that should have been uploaded to downloads, not clips. Well, kind of don't have the right nomenclature here. But anyway, once this is uploaded, we can just drag that folder out into our downloads folder. And then we'll actually just run the exact same script, just with a different pathing here. Let's see how we're doing here with this. Almost done. So 10 seconds left. So one thing to remember is in Colab, you can only run one cell at a time. So while this cell is running, the entire machine is essentially taken over by this process. So we could look at batching this. Actually, you know what I will do for next week is I'll write a script to show how to batch this. But for now, I would just run this on like individual clips just so you get in the habit of doing this. But for next week, I'll make a little batch script that we could do to run this on a bunch of batching, and then you could run it overnight, that sort of thing. Okay, so this is now done. Let's see if our file is uploaded here. Looks like it is. So we'll come back over here and refresh. And sure enough, all of this is here. So let's just drag this folder into downloads. And then what we'll do is we'll come down here and we'll just copy this path again. And let's make a new clips folder. Let's call it NYC dumping. And we'll copy this path as well. And then we'll paste this in. And then we'll just run it. So PyScene Detect should, I believe, work on MOV files, MP4s, AVIs. I think it'll probably be pretty flexible. I don't know. Maybe there's some format that you're going to give it that will break. But we can kind of see how that goes. So we'll see it's now detecting this. It has found 2 scenes so far, which is good. It's probably that intro and then the actual scene itself. So I think if we're lucky, we should only see 3 scenes total detected. Four. Okay, so this will be kind of interesting to see like what it actually decides are the 4 scenes. But it is now running. I know a lot of this output looks kind of like, oh, you're like, oh my god, what is this? For those of you not used to coding or that sort of thing, but don't worry about it. Unless you see something that's like bright red that says error, that's the only thing to really worry about. Or if you get an error message where it like puts a red circle around our cell. In general, this tool should work as expected. And we'll see this should only take, by the looks of it, it should only take about a minute. So let's see what we get when we're done here. Actually, while this runs, let's go and check out what our Groundhog Day footage looked like. So we'll come back here and we'll go to Algo Film, and then we'll go to Clips, and then we'll go to Groundhog Day. And you'll see we got 93 clips because it starts at 0. Actually, it starts at 1. Oh, 92. Maybe that's the right amount. And then if we just click on these, we shouldn't see any breaks, right? So that looks pretty good. We shouldn't see any cuts in this. Yep, that looks good. I'm just going in and just randomly sampling some of these. I actually think this one's going to look really fun. I'm kind of excited to see how this looks when it's all put together. Lots of Bill Murray faces. Okay, so I think this looks pretty good. So in that regard, I think we're pretty close to being ready to play with that. This is still operating. It looks like it's going to take about 2 minutes left. So one thing I will mention, and I'll post a link to this as well, is I ran this on a full movie earlier this week. It is, where did it go? So I ran this on the movie Memento, which I thought was kind of good because it's all about like, you know, weird sequences or like non-linear editing. So I made it even more non-linear. And I did notice, actually right there at the beginning, you notice that. All right, sorry about that. My screen recorder decided to shut off. But this is the film Memento, which has been sort of reshuffled using this process. And if I look through here, there are moments. I think you could see it right there if you caught that. There are some moments where it seems like maybe the first frame or two is, yeah, you could see it right there. So these cuts are not always precise. And this is where, if you really are concerned about precise cuts, you might want to look at something like Resolve. I have a feeling that this is because I downloaded this video from some website that I probably shouldn't be mentioning. I torrented it. And usually torrents are very, very compressed video files. And sometimes that means it does compression around those cuts very weird. And sometimes that can trip up something like PyScene Detect. So in general, long videos from torrent sites might not be the best. It might not also just have something to do with this video, but I did notice that it wasn't perfect here. And this is where the next video on Resolve might be better. But for now, I think this is good enough to sort of work with. And if I come back over here, I'll see that my video ended with this. So it should, I can now check out that clip. Let's go to clips. Let's go to NYC dumping. And I actually got 5 clips. That's interesting. So let's go 1. That's good. I don't actually need that one. So I might actually delete that one, right? If you don't want some of these clips, you could just move them to trash. Let's see about 2. That looks pretty good. Let's see if it turned any of these other things into crops. There's that white flash there. I bet you that white flash is what threw off. Yep. I think that white flash is what threw that off. And that's one of the challenges with these tools, is that if there is something that is really flickery, flickers will tend to be lost by this. And this is a case of where you might just, in this case, it's one actual long piece of footage, so I might just like crop this manually. Whereas, you know, with something like a full feature-length film, which is an hour and a half of footage, I might not want all of that. Yeah, I think there's also some other damage to this clip that is also causing this to not work correctly. So here you will see this is not the perfect solution. This is algorithmic tooling. It doesn't always do the right thing, but it converted a single scene into 3 clips. Not perfect, but it's close enough. Or like in this case, it sort of shows like, oh, for this type of thing, I probably shouldn't use this tool. So if you've got really old footage or really destroyed footage that has like flickers in it, or if you're doing like abstract stuff where like things really flicker by, this tool will not work that well for you. But for like traditional like long shots that are pretty modern, probably gonna work fine. So in the next video, we'll look at how to do this in Resolve, and then we'll also look at how to bring these clips back together to do something like this Memento piece. So I'll see you next time.